Okay, so let's put all that together. We are going to look at a lot of different methods. This gets very confusing, but I'm going to go slow with you and try to get you to appreciate and understand how each of these things work. Not get you to memorize them. You will not succeed in this chapter if you're just a pure memorizer. You've got to understand the concept of what's going on. So we're going to talk about the disk method today. We'll probably stop at that because I don't want to overload your brain with the washer method also. And then, of course, your goal for today, you may have already accomplished this goal, I don't know, is give 2 hugs today. Anybody?
I gave a negative hug.
Vegas? What exactly does a negative hug look like?
It's like what you do to your parents.
Sorry, I was going for a handshake.
You come in and they're like, no.
No, I was going for a handshake and they were like, oh.
That's awkward.
I know. Negative hug.
Can't talk to him again.
I wouldn't, see, if I was given the hug though, I wouldn't have slowed down, I wouldn't come in anyways.
No, but I stopped and I was like, really cute.
So you didn't want the hug. Why?
They smell bad.
It's just a pure concern and the concern and desire to make sure that their well-being is taken care of. Okay, that's commendable.
Thank you.
Negative hug, I like that. Here we go. All right, so we saw this already. You take a rectangle, and this one is a big honking rectangle, just so you can see it, and you spin that puppy and you get that disc. Initially, I'm using W as the width of the disc. You would probably think of it as the height, because that cylinder would be turned on its side. And then there's a reason why I'm using capital R for the radius. You've always used lowercase r for the radius. But I know where we're going, and I know that at some point we're going to have 2 different radii. So this one will be capital R. And there's some terminology in there. We've already talked about axis of revolution. This is going to create a solid of revolution. It's a solid created by revolving things. And we get that nice, neat little formula. That's the formula we've already done. We just changed the variables a little bit. Pi r squared times h becomes pi r squared times w. Now the examples that we looked at, we had a bunch of jagged edges on it, and we don't want that. We want a nice smooth figure. How do I get rid of the jagged edges? What can you tell me about w? W? That's it. Good. Or dx or dy or whatever we're working on, right? Which means what's going to happen to its size? Good. Okay, so here's a picture on the left of a function. That red function f of x is some little weird looking thing. And the area underneath is broken into rectangles. By the way, you've seen something like that before. What does that remind you of in calculus? Say again? Yeah, good. You remember what that was called? Who's it named after? Riemann sum, right. That looks like a Riemann sum. And we talked about this already. When we had Riemann sums, we wanted a more accurate answer. You can see even in that picture, there's a whole bunch of open gaps in there. And when you spin it, you get this tiered volume thing. And we don't want that. We want a nice, easy curve because the original function has a nice, easy curve. That's illustrated here. If I can figure out how to smooth that out, then I can go from the right-hand side, which is the big honking, meaty, rectangle, brown-looking thing. I'd ideally want to be the blue thing in the middle where you've got a nice, smooth curve. And how do I do that, Lucy? Yeah, make the rectangles really, really skinny. Or create an infinite number of them. Okay, either one works. More than likely, we're going to use the bottom one to minimize the thickness. Which means our W is going to turn into dx. So very skinny rectangles. All right, let's stop for a second before we dive into an example. Do you understand the concept of what's going to happen here? Find the volume of one disk, i.e. cylinder, Then add up all those cylinders, and you will end up with the volume. Yes? Beautiful. Okay, draw that. Sketch it. So you got something to work with. Oh, by the way, x equals -2 and x equals 2, are those vertical or horizontal? Okay, just checking. Good job. I'm proud of you. Let's feel good for everybody. Don't be sorry, it's fine. You're good. Oh, that's how it should go. That's what you think of everyone. My gold face. They're all I'm sorry, what was that? Haters are having both of these? Oh, nice.
I got some in my bag. I got 3 of the wild cherry.
Okay, so should look something like that, yes? Now the good thing is you won't have to draw sketches like the green one on the right. I don't care what the 3D model looks like. You could visualize it if you'd like. You could draw it if you're feeling saucy. What I care about is the yellow one. Okay. So, before we dive into this, what do you notice about this particular problem? Or do you notice anything about this particular problem? Ah, very nice. So what does that mean? Okay, good. We'll come back to that in a second. Okay. All right, so I need to spin that blue rectangle. And when I spin that blue rectangle, I'll create a cylinder. I'm going to find the volume of that cylinder. And then I'm going to integrate over an interval from what to what? -2 to 2. Okay, so I'm gonna take you through some self-talk that I use to help you with this whole big picture. These questions are gonna seem silly initially, but when we've looked at 4 or 5 different methods, it will help you to understand what you're supposed to do. So first thing, is my rectangle horizontal or vertical? It's vertical, okay. If it's vertical, that means I'm gonna work in terms of x. So all my equations should be in terms of x. I have a dx on it. My limits of integration are in terms of x. Okay. Question number 2. Is my rectangle perpendicular to or parallel to the axis of revolution? It's perpendicular to. We're spinning around the x-axis here. Okay. If it's perpendicular to the axis of revolution, that means you're going to do either a disk or a washer. We're just going to focus on disks today. How do you know which one? Well, that leads you to another question. The question is your rectangle touching the axis of revolution? In this case, it is. If it's touching the axis of revolution, then we're doing a disk. If it's not, then we're doing a washer, and that comes later. Okay, so that has it narrowed down to a disk. What's the radius of that disk? In other words, how tall is my rectangle? Which is? Which is?
2x squared plus 3 minus y-axis.
Which is? 0. Good. So I heard a lot of different things, and they're all correct. Top minus bottom, that still applies here. Y minus 0. What's y? X squared plus 3. X squared plus 3 minus the x-axis, same thing as 0. Okay, that's my radius. There's the area of the rectangle. Top minus bottom, x squared plus 3 times its width, which is dx. We want a really skinny rectangle. And then we want to create the volume of that cylinder. So the volume of the cylinder becomes that. Notice that the radius is that height of the rectangle, x squared plus 3. So that bottom equation is pi r squared times w, which is what we saw earlier. But like we said, w is going to be dx because we want it to be really skinny, and r is going to be the height of that rectangle. Okay, let's stop for a second. Does that make sense? Yes. Any questions? Yes, sir.
Why is WDX?
Because if we go back in this one, the brown one, we have a W that's a big honking number, and we get these jagged edges. We want it to be smooth like that. So we, what just happened? That was weird.
This is when it's like multiple screens.
Yeah, it went multiple screens for a second. Wow. I didn't touch anything. Maybe my sleeve touched. Okay, regardless. If the W has a width, then we see those incremental steps. We want the W to get really, really tiny. So tiny that it's almost zero, which we refer to as the differential dx. Okay? So where were we? Okay. Question?
Yeah. Do you just always multiply pi by the area? Like, will it always work like that?
Yep. All right, now I did a couple things to make my life a little bit easier. I moved the pi out in front because pi is a constant. And I went from -2 to 2. However, how does symmetry help us here? Do you have any idea?
You can do 2 pi to the n and half from 0 to 2.
Good. Since the left-hand side matches the right-hand side, you could do that. Just to make sure your calculators are good to go, FN int that to get that, to make sure you can get that number of 253.841. Get out your calculator. Yes, sir.
How'd you get x squared plus 3 to be on?
It's the height of the rectangle, so I'm taking that rectangle and spinning it around this way, so that's going to be the radius of the cylinder.
How'd you know to set x squared plus 3? How'd you know that was a radius?
Because that's the, so the axis of revolution is the center of the cylinder, and that distance up is going to be the radius.
Oh, that's the function.
Yeah, it's top minus bottom. Okay, we good to go? The integral should give you 80, and then you take 80 times pi, and you get that weird 253.841. Most common mistake in these types of problems is forgetting to multiply your final answer by pi. Okay, don't forget that pi floating out in front, it's important. Okay? Questions? You think you can do this on your own?
Yeah.
So we'll see. Question? I'll get to that in a second. All right, we're going to stop here. Now, I'm stopping here for a couple of reasons. We will change a whole bunch of things about this. So, for instance, we just did the disk method. There's also the washer method, obviously. Then, to make things more interesting, we'll take the disk method and do it in terms of Y with horizontal disks. We'll take the washer method and do it horizontally also. And then if that doesn't get any worse, we'll also introduce something called the shell method. All of these do the exact same thing. So I want to be sure that you have the disk method under control before we move on, because if you don't, you're just going to be dead in the water. However, tonight's homework has both washer and disk method problems on there. Obviously, you can't do the washer method yet, so I'm going to go through that self-talk again that I used to help you figure out whether or not you can solve the problem. Is your rectangle vertical or horizontal? If it's vertical, you're working in terms of x. If it's horizontal, you're working in terms of y. Is your representative rectangle perpendicular to or parallel to the axis of revolution? If it's parallel, we don't know how to do that yet. If it's perpendicular, it's either a disc or a washer. If it's touching the axis of revolution, it's a disc, you're good to go. If it's not, it's a washer, and we haven't done that yet. So skip that. Okay, make sense? Good. The quiz, I moved back to Friday, because we're going to need some time tomorrow to go over all of this stuff. Tomorrow's homework is just continuing on with this stuff. You'll see on the calendar, I didn't switch days Thursday and Friday, because we need to make sure we've got this under control. Tomorrow in class, we're going to go over a lot of these disk method problems and then talk about the washer method to progress through this. The quiz on Friday is only on area, which is 7-1. Okay, are we good? Any questions? Go, dog, go. Yeah.
What days of homework did we turn in earlier this week?
97, 98 together, then 99 and 100, separate.